Hey folks, sorry I'm late. Let's get going. Hey Rachel, long time no see. Can you guys hear me?
Yes. Yep. Can hear you. A long time.
Yeah. Welcome back. Good deal.
Thank
So
you.
have you taken a crack at this competition or?
Yeah. Yeah. For the last 3-4 days.
Yeah, where have you been,
Oh,
Raquel? You been off hiding?
Hey, Steve.
How's it going?
Good. Good. How about you?
Not too bad, thanks.
so any progress? I haven't checked in the last day or two. I caught up or came close, but still 150 points behind you, Steve, because I was still off by a single hundredth of a decimal point, but it begins to count, I guess. So were you able to do more on this competition over the last week?
I've just been sticking with my strategy of taking the highest public leaderboard and copying that.
So where is that at now? I didn't try that in the last several days. I kind of, by the way, those videos are excellent. I would highly recommend everybody to go look at it because the videos that you referred to last week really give a good understanding of where perplexity matters and how the perplexity approach works for these large language models used in this case, and also what the open book guys are attempting to do by providing more context to the debater model. So at least the 4 videos were, I thought, really excellent because they kind of give you the exposure to the underlying reasoning behind both these approaches. Of course, the rest of it is what matters in terms of implementation, but the bigger ideas are covered by Jono, who talks to those 4 videos. So those were excellent references.
Yeah, no, I thought they were very good. So, yeah, so far I'm up to, I think it's 837 is the highest public leaderboard score. So that's where I'm at. That just about gets you into, I haven't looked in the last couple of days, but it was still getting them into a bronze medal place, but you're down about 150 to 200 or somewhere like that.
Yeah, and I think you're at 1 something or 2 something. I'm at 3 something, and basically.
Yeah.
But anyway,
yeah, so like obviously you're not going to win the competition just copying people, but it sort of keeps you up there on the leaderboard at the minute. And
yeah.
so
Also, go ahead.
I was going to say, yeah, so there was like two notebooks like the last time I looked were sort of neck and neck, but there was that one that we looked at last week, the fork.
Yeah.
Yeah, like I couldn't get it to work. Well, I couldn't get it to work and give me the score that he was getting.
Yes, same here. I tried that. It gave me a score a lot less. I think 8-1 something. So I switched to using a different one.
Yeah.
And that gave me, instead of the 8-3, whatever, that 8-3-7 or whatever, I got, I think, 8-3 something less, which is why I'm like 100 and something. But bottom line, I think both of them were using exactly the same approach of just providing more context to the model and using the open science and the reference. And that's where I was running. So if I could ramble on for a minute, the open science approach, basically, as I understood it, and as Jono explained it in the videos, is providing context from Wikipedia using the questions text as kind of a reference to go extract the relevant Wikipedia text, convert it, tokenize it, and then add it as a context to each of the questions, and then just get a score based off that. It's kind of as simple and as complicated as doing that. So the thing the next step obviously is, instead of the debater model, and you can think of this pretty much kind of independently of this approach for this particular problem. There's a lot of this discussion of how do you customize the LLMs in general on your specific data? And that entire process is often referred to as RAG, or retrieval augmented generation. And the retrieval basically is equivalent to what we are doing in our code of going to the Wikipedia pages and retrieving the relevant context. And similarly, if we wanted to tune LLM on our model or our data, quote unquote, personal data, then what you would do is, instead of going to Wikipedia, you just go to your own set of data and augment the model, the LLM, by fine-tuning it on your data. So it's this whole RAG fine-tuning approach that I think the rudiments of which are implemented in the open science approach of going and getting Wikipedia data and augmenting the context for the LLM. Now, the next step obviously is, instead of using the Dakota model, is to just use a LLM 7 billion model or whatever. But I thought, one of the things why the Dakota model usage is still somewhat relevant or somewhat material is, if you look at the kind of the spirit or the goal of this competition, is to see whether smaller models can somehow mimic as much as the big LLMs can. Now, of course, if you use a 7 billion Llama model, Llama 2 model, you're still using a smaller model compared to a GPT 3.5 or a GPT 4 model. But, at some point, you're kind of approaching using an LLM to address the LLM problem. So I don't know whether the best guys, who are at 0.91 or wherever they are these days, are actually fine-tuning a Llama 2 model using the same RAG or, open science or open book Wikitext context, but provide it to a Llama 2 model rather than to a Dakota model, and thereby getting a better score. Because at that point, you're just limited by compute, whether you can train a Llama 2 model to do that. And, obviously, that will require some of the things, Steve, that you've been fiddling with, which is, I forget now, what is it, Dart, or what's the public computing GPU source you were using? I forget the name of it now.
Oh, Vast AI?
Vast. Yeah, Vast AI.
Yep.
But the paper you were showing is very fascinating. What is that paper, or can you talk more to that?
Yeah, so as I say, like, I've been going through these public leaderboards just so far, just picking them. Yeah, there was a bit of difference during the week, as you say. So here's the fork of fork one. This one here, if you click on there, there's about yeah, so you can see he's got it pinned at version 5.
Right.
Whereas, yeah, so it's like showing whatever score he got, but I think it's like for version 11 or 12 or whatever. And it's hard to pull out a specific version. And yeah, so I tried that, but because of the fact that things move, some of the models and stuff he had in the background weren't there anymore. Whereas, yeah, so like then I reverted to, I think it was this one. This one here, yeah, this notebook here is a bit different. His fork of fork one, he's just sort of manually come up with weights for each of the models in his ensemble. Whereas it's one of these ones, I'm pretty sure it's this one. And it actually uses a strategy to like try and find the weights to use for the ensemble. So like it was better and it worked. And I think it was the one that gave me like an 837 or whatever. So
and what, if I may, what kind of strategy is using to optimize the weights in the ensemble?
I think it's this one. Maybe it's not. I'll just take a look and see what I submitted, because yeah, the one that I submitted, I haven't been through it all yet, but yeah, so this one.
IX optimized ensemble weights.
Yeah, so like he explains all the type of strategy he's using. I haven't been through it yet, but Yeah,
Oh,
so
okay. Interesting.
this one here sounded a bit better, and it's more a bit more scientific as to what he's doing, into how he does it. But yeah, like anyway, so yeah, so you can just pull a model out of the public leaderboard with a high score and do that. But yeah, so people are just like sort of tinkering around the same open book models now, just sort of trying to fine tune their ensembles to slightly move up the leaderboard. But I presume the people at the top aren't doing that. So yeah, so I went off and like, there's this paper. And yeah, so what this is like saying is basically, yeah, so do you know the one we're using at the minute? It's like using DeBerta, and it's using the DeBerta multiple choice question answering
Right.
fine-tuned
Yeah.
thing or whatever, where you have to put the
Yeah.
question in 5 times, one for each answer. Whereas
Yeah.
like this one here, yeah, so like he sort of compares, there's actually like on, what do you call it? On here, yeah, papers with
Yeah,
code.
I went there too. Yep.
Yeah, so like there's a leaderboard for multiple choice question answering. So like the people that do this paper are sort of saying, yeah, that within that there is, I think it's called open science question answering or something. There is a specific multiple choice data set. And this paper here says that by just fine tuning a single LLM, that they can sort of get up to where sort of bespoke models for those other things are, and they can like generate, yeah, so this open book QA is the main sort of data set for sort of testing this type of model. So you can see here they've used like all these different types of model, but what they found was, yeah, so like the best ones they were getting are these two, Codex and Instruct. So like they would give better results even than GPT. Both of these are actually built upon like GPT, but they're actually fine-tuned for doing code completion, like writing code. And like they they sort of guess that because it's fine-tuned for sort of being logical and putting code in place, putting like a sequence of code things, that it's better at sort of guessing ABCs when you come to multiple choice questions.
Very interesting.
And yes, like they give at the bottom of this, they
quick question
give
while you're on that
prompts.
graph. What is this Da Vinci or something there? As in the bracket, what does that
Also what?
indicate?
Oh, Da Vinci?
You know, they say, yeah.
I think that must have been the sort of the code word name for the GPT version that they're using.
Model. Okay.
Yeah, so like I think GPT-3 Da Vinci is a particular branch of GPT-3, and like these two are both fine-tuned upon it. So yeah, so I think that's what it is. But like obviously from our point of view, the fact that these models here are better than GPT-3 doesn't really help us in the slightest, because of the fact that they're still going to be massive and too big to pull into Kaggle. But the other interesting thing,
that's where.
yeah, the other interesting thing about this paper is, yeah, so like it gives you all the prompts that they use. Yeah, so it shows you the prompts they use for like each sort of data set. So you can like take this and find sort of the prompt. So that's what I've been doing now is like, yeah, like trying to train my own, as I say, like I can't put GPT-3 into Kaggle, but I can put Llama in. So I've been like trying to fine tune Llama or Llama 2 even. So yeah, so you can run that and it'll run and give you some answers. So you can see here it's produced an answer here. The real answer is B, but that's probably just I haven't tuned it enough yet.
Yeah, the thread you were on is what I was beginning to think about, is using Llama 2 to do context and this retrieval augmented generation technique,
Yes.
which is basically just a fancier way of saying implement the same open book, but do, like try to do llama fine tuning, because that's the next thing beyond Liberta, right? Is go to a model, but obviously it can't be so big that we can't derivate it. But then the only choice we are left is llama 2 7 billion or llama 2 13 billion, and see whether any one of those can be trained on Colab with, or even vast AI with the resources we have, and see whether that gets any better. But the challenge there that and in fact, it's good, yeah, if you can post some of these, even the paper reference in Slack, that'd be great, because I immediately went exactly where you're going. Are there data sets that we can, or multiple choice Q&A data sets that we can fine tune on? And the other challenge we have is with the Llama 2 kind of stuff is, so far at least, the only thing we have seen in the notebooks is perplexity-based scoring, right? And instead, here we are actually interested, or we would be interested in not perplexity, but actually scoring it using our whatever the map tree with results, and how to do that without going through the whole prompt routine. So
Yeah.
how are you judging, by the way, the results here?
Well, yeah. So like there's this notebook, as you say, though. Yeah, so when I stick the prompt into Llama, I can get it to tell me what you think the answer is, and it'll tell me the answer. And so like I'm fine tuning it, so I only get one answer out like that. This one here, this notebook that's in Kaggle, it's quite good. But again, like down the bottom, when it comes to get its final answers, even though like it's been using prompts and telling it to give me an answer, then it drops back to perplexity again to sort of measure itself. I'm not sure, is that because when you use the prompt, it'll obviously say, I think the answer is answer A. And so you don't have, we need 3 answers to work out a map score. So I'm not sure, is that why they drop back to perplexity? But
yeah, of course, you could always run it and try and see with a prompt of like, give me the 3 best answers and give it, go that route. But
yeah.
I'm yet to see anybody try that approach and move away from perplexity to judge that. And while we're on the topic, I thought one thing that I think the guy, the Jono did, which I think is a clever idea, is he used the 200 examples as the test set for some work. And I thought that now that's actually a pretty good way to judge if you're running on Colab or something and don't want to score yourself on Kaggle. You see what I mean? Like generate output on not, train it on not the 200. You could train it on the 1500 examples or other things that Radek is produced, and then use the 200 examples as your test set, because that's a small enough test set that it ought to really quickly give you the results outside of Kaggle and give you a score, a map3 score. So far, I haven't seen anybody get perplexity scores, which are, even Jono, he just illustrates the example, but he doesn't get any good score anywhere near what people are getting with the open book kind of approach.
No, but during the week I also saw this. It's somebody has like there's like the 60K data set knocking about. So they've gone in and sort of manually tidied it all up, and they've like split it. So they've made like a validation set on it now. So there's 1,000 questions for validation. So I've moved over to using this and like use their 1,000 validation set, because it's like sort of clean and been all tidied up. And yeah, like then I run the map3 score locally. So like when I do that, yeah, like it's giving me a very similar score to what I get when I do an actual submission. So yeah, and the best like Llama one I've seen I've seen one of the Llama ones or whatever, but it was like fine tuned and like with it, I think I've got no, it's not this one. One of my models anyway, it's got using that data, and then I stick it through my own map 3 score. And yeah, with like a fine-tuned Llama model, I get about a 0.72 or something, but that was tuned without any context. So I was going to try and tune it again with context. Oh yeah, you can see here. So you get this score, and like that's a Llama 2 model. So that's not using perplexity anymore. That's just sticking the
So is
answers
that
into the
your
model.
notebook or is that a public
Yeah,
notebook or?
no, there's my notebook.
Okay.
Yeah, so it's yeah, so you can see here, like I now take the context and stick it in the question and
Right.
the 5 answers, and then stick them in, and it returns me the way it's like designed. So like it always returns an answer at the end. So you can see here it got it wrong, but
But does it return one answer or three?
just one. Yeah, so that's the trouble. At the minute, it just returns one. So you're either right or wrong. Sort of, you don't know what the other possible answers are. So,
Right. But is
but
that
yeah,
because of prompting, the way you're prompting, basically?
yeah. So I just tell it to give me the answer that it thinks right, whereas I can maybe change the prompt to say, give me the answers in the order that you think are the best. So
Yeah, actually, you should use this function thing that Jono talks about.
yeah, I'm not sure if that function thing though works for anything other than GPT. I haven't seen it for Llama.
Oh, really?
Yeah, I think it was just
Oh,
GPT API.
Yeah, so I don't think you can use it.
okay. I didn't realize that. That's kind of sucks because I thought that provided a kind of a neat JSON like, but then you could convert, if that doesn't work, the other thought I have is there is a fast AI. I'll see whether I can post a link to that. There's a very simple, not fast AI, deep learning AI course that, what's the guy? The Stanford guy, and somebody from OpenAI taught a very simple 1 hour kind of thing, prompting OpenAI models.
Yeah,
And the reason I'm Andrewing, yeah. The reason I refer to that, I'll see. I think I might have posted a link to it somewhere. But anyway, I think I have some link to it lying around. But if, the reason is one of the sections I recall in that gives you a prompt that enables you to get a JSON output from the model, from the OpenAI model. But that's a generic enough prompt that it doesn't do this function thing, but you can make it return a JSON. And I think that prompt will help you to get from a Llama to 3 answers rather than 1, and give it back in the format like a JSON, and you can post-process it into the format that we would like.
Right. Yeah, I did
I'll
find
post
like
that link.
yeah, I've got this thing. It's like a data collator, and you can put your response template in there. So that's what I'm using at the minute, and like that's how I find the answer in the result that comes back out of my trained Llama model. So I'm not sure if I can change the response template and with the thing and tell it to sort of give me more than one, but not sure.
What is the data template thing? Is that
Sorry,
is it generic to any LLM or is it specific to Llama 2?
I think it's for any of these. I think it's for any language model.
Yeah, that looks like a Hugging Face thingy, data collator for completion.
Oh, it is Hugging Face, yeah. But I think it's for any model that Hugging Face have. And then, yeah, I've also got, yeah, so like when I'm sticking it in, I'm sticking that. Yeah, so perhaps I can change. So at the top of every prompt, I put this. So maybe I could change that to say answer should be top 3 among that.
Hmm. Sekil, you were going to say something?
Yeah, so I was just saying that even with Deberta to start with, I was thinking more than like training the model to understand the science question, it's more about making it use the context and then go ahead and find the answer, right? You're not trying to train Deberta to understand the science aspect of it. And Llama being a much bigger model, like is obviously trained way more than Deberta and knows more than Deberta. But the 7 billion model is just a language model, so it's just going to be autoregressive. So fine-tuning there with a context, like at least that's what my understanding was, probably a better idea, though I don't know how long that takes to fine-tune. How long did it take for you, Steve?
I was running with 10% of the training data, well, 10% of the 60K. So
Oh, okay.
6,000 training examples, and it took me 12 hours
Okay.
for one epoch.
Right. Okay.
So yeah.
Wow.
Probably took me
Were
like
you doing it on Vast or Colab, Steve?
oh, that was in Kaggle.
Oh, on Kaggle. Okay.
Yeah, so I used all my GPU time.
Yeah, like for example, the Deberta model, I think with freezing stuff like what I think Chris Stewart was doing, that itself takes me like around 8 to 10 hours. So that's why I was wondering, like, did you guys try to fine tune Deberta to start with by unfreezing stuff, or have you guys frozen and like changed other parameters on that end and tried stuff?
I was running like Christy Ott's training one on the Deberta one, but yeah, I kept running out of GPU memory, so I gave up on that.
Okay.
I was going to use the Vast thing, but then I decided to go off and steal people's public ensembles instead.
Okay.
But yeah, so I'm back on it now.
Oh, okay. My unfreezing everything on an A6000 is predicting like around 20 hours for one train.
Wow.
So yeah, I'm waiting to see. But at least the loss is going down, and I kind of see it hitting around the 0.7, 0.6. And yeah, it's like just finished 2 epochs yet, and like 2 more to go. So at least from what I was reading, people were talking about dropping it down to like 0.5 or so. And my training loss and validation loss, the gap isn't that wide. Yeah, so I'm just hoping, yeah, the Deberta V3 seems, yeah, like a more plausible option for me than the Llama one.
Yeah.
I pulled out, I think one of you posted Abhishek Thakur's Llama video, and I saw if I could run that on Colab, and it did run, but yeah, again, it takes a while on A100 itself over there. It took me, I don't know, 10 hours again, I think, something like that.
Yeah, and my thing is it just wipes out almost a month of usage, and then I have to pay again to get the next month and stuff. And then I've been also fiddling with the stable diffusion course that you finished up, Sekil, and we are going through it. Mayank and I and we and stuff are going through it in 8 to 10 in the morning, and we're kind of close to the end, but that takes up another chunk of compute.
Nice. Okay.
I'm like, man, it's just all a compute challenge.
Yep. With the testing out, like actually, yeah, before jumping off to RAG, from my understanding, what RAG was just looking up for embeddings, retrieving context, giving you that, and then fine tuning is the separate aspect of, I don't know, moving like a 7 billion model to a code generation model or whatever specific task you want. So RAG and fine tuning are like two different things. Is that what you were also saying, Srinivas?
Yeah, I agree. I think, but what I was trying to think of is where, see, because the context so far has been, at least in this competition, primarily used in the inference phase, right? Not so much in the training. It's used in both, but it's, they were providing, as I understood it. I haven't looked at Chris Riot's training notebook to see, how much of the training phase he is using the context from the Wikipedia stuff to train the Beta V3 model. Can you speak to that?
So that goes into like each row, you're basically concatenating whatever your prompt is, which is your question. The related question is queried against this Wikipedia science articles using face. You get back the context, trim it down to whatever size you need. And then you have all these answers attached. So the whole thing goes in. So like each row of data is question, context, answers.
Okay. So you are training with the context as well. But that's, again, that actually, so, that's different than this RAG fine-tuning for LLM thing, right? Because there, as you said, in RAG, it's more the embeddings itself we change, and then the fine-tuning is where you may do things like what you're doing with the beta, which is modify just the weights of the model and are not changing the embeddings at that point.
Right. In both the cases, you don't touch the embeddings per se, because the embeddings is only going to be used for, again, like moving on, when you move to inference, you want to see your new question comes in, you convert it to these embeddings, and then that embedding is going to do a lookup on your wherever your Wikipedia stuff is stored and find a relevant context. And you use that context as part of the prompt saying that, okay, this is my question, this is the context, these are your options, look up and give me the answer. So I think in one of those discussion boards, Chris kind of mentions this, where he talks about like, you're not really trying to focus on trying to make the models understand science per se, because they already know that. It's more that you're trying to make it understand, look into this context to find an answer.
Right.
So, yeah.
Or even more precisely, look into this context to pick from among the answers given what is the best answer.
Right, yeah.
Right, because even the choice is, the choice is already constrained for you by given the 5, but the context helps you differentiate between the 5.
Yeah.
Amongst the 5.
It should help you understand, what the 5 are. And so that's why I was wondering, like, because you stack them all up like that consequently, in essence, changing the order of A, B, C, D, and shuffling that order will potentially basically give you like not different answers, but they're like different inputs to the model. And I was kind of thinking, does that make sense, or am I missing something there?
I also tried that this week. Yeah, so like I thought I'd be able to like swap all of the answers around and like effectively get 120 different models by putting each one in. But if you're using the multiple choice DeBerta thing, it actually does one at a time. And so I found that it just gave me exactly the same score back for every single one.
The DeBerta one, correct. Yeah. The DeBerta one, I think, right. Okay. Those are paired as question, answer, question, answer, question, answer 5 times, right?
That's right, yeah.
Right, yeah. So there, yeah. But the Llama one, I don't think, at least from what the notebook you were sharing, that one stacks everything together, right?
Yeah, no, so the Llama one, I think that'll work. So yeah, I was going to try that. I was only going to try it at inference time because it would take me, as I say, it was going to take me about a week to train it already. If I do that as well, it would take me the rest of my life.
Yeah, I was thinking, that'd be great, like test time augmentation to kind of use that and then ensemble or take averages from there.
Yeah, there's actually in the discussion, there's a discussion about it because like somebody found that yeah, they would get like different answers
Ah, okay.
back out if they changed the ordering of the questions going in.
Hmm.
Sorry, the answers going in. But
Makes
yeah,
sense.
so like I was going to try that to sort of, yeah, as you say, get test time augmentation on it.
Cool. Okay. Awesome.
Yeah, see, that's where.
Sorry, go ahead.
Sorry, go ahead. Ritu.
No, go ahead.
My thinking was that that's where the perplexity-based approach falls apart, because the perplexity basically is just essentially relying on this autoregressive nature of
Yeah.
the model and just kind of judging it from that. So I felt that at the end of the day, I don't believe, regardless of the complexity of the model that you're using, that the perplexity-based approaches will get you anywhere close to the other methods of judging the model, because as John explained, perplexity, you get to 0.6, 0.7, but beyond that, essentially, even what you're trying to do with perplexity is just say, oh, the likelihood of the perplexity being lower for the correct answer is more, and that's kind of what you're relying on, which seems to be a very indirect and a not very effective way of getting the answer quality, because that's what you're relying on when you rely on perplexity. So that's why I was feeling that, using a large model, but then bringing in a better judgmental or a better metric is needed for sure. But there's a limitation to how far the perplexity approach will get you.
Thinking about this right now, but yeah, I haven't put much thought to it. But I think I kind of, don't completely agree with that, because the same thing what Steve was doing with, let's say, Llama 2 fine tuning, you fine tune, and at the end of the day, it's like at inference time, it's zero shot that it's going to happen, right? So your model has learned, Llama 2 has learned whatever you tried to fine tune it on, and then you're asking a zero shot to give you your answers A, B, C, D, E. And if you now go ahead and do the perplexity approach on the fine-tuned Llama 2 with the same thing, I think that should still kind of, in essence, give you the same ish results, at least from what I'm thinking right now.
It should get better, but the difference is you are doing this initial step in what you just described, which is fine-tuning the model using the context. And that fine-tuning is actually changing the weights, after which you are getting the model to predict, which it does based on, at the end of the day, any of the Liberta or Llama or whatever is always using the autoregressive nature to finally do the predictions anyway, right?
Right.
That you can't get past regardless of which model you're using. As long as you're using a LM, forget about an LLM, you're always, that's the only trick in the book.
Right.
But all I'm saying is if you're just judging the answer by perplexity, then I'm saying that approach is going to be not, it's using perplexity to judge versus eventually the model, regardless of what nature of model it is going to use autoregressive methods to predict the correct answer. That there is no escaping from. Right? But judging the correctness of an answer by using its perplexity.
Right. Okay, I see what you're saying. Okay.
Is what I'm commenting on.
Okay.
Which is the only way that the perplexity scores of any LM is if you use perplexity as a judgment on the model with respect to the results. because that's, at least as I understood from Jonas' explanation, that's what you're doing when you're using perplexity,
Right.
is to score the model.
Mm-hmm.
Versus fine tuning and anything else, you're actually changing the weights of the model, and how the model predicts is eventually only autoregressive. There's nothing else the model knows.
Right.
So I guess that was my thinking of why we ought to do something different, or that's why you can see everybody switching away from perplexity. And my guess of the 0.91 guys is essentially they're doing what you and Steve are attempting to do, which is spend the compute hours to train either the Debata tree itself or the Llama 2 model with context. The only
Right.
thing then at that point you need is lots of compute.
I think, yeah, like have any of you tried changes to inference, like what kind of context you're returning back, how much of context, trying to split that sentence up, playing around with that side of things?
No, I haven't done that. I was just writing down, like you said, the thoughts on what, what even approaches to take that would entail reasonable compute.
Okay.
At the minute,
because
the notebooks are all based on the open book original notebook. Yeah, so they all use the context thing, and like that's how they've sort of got like gradual improvements in the score, is by sort of improving how they find the context relating to the
Okay.
questions.
Okay.
Like people got a big jump. Originally, they were just using the question. They would use the question and then try and find the Wikipedia pages that matched the question. And then they found that if you started appending the answers as well when you're looking for the
Oh, okay.
context,
Okay.
it improved it quite a bit.
I see.
So,
Okay.
so yeah, so like they've sort of improved how it searches for the Wikipedia pages that would match with the given question.
Okay.
the one thing I was thinking of, Steve, is I should spend more time with Chris's or the open book approach. I was wondering whether maybe you know the answer already. That here as I saw it, he was or they just go and get a bunch of Wikipedia articles, right? It's not anything specific, more specific than that. And I was wondering whether if you could make it a little more specific based on the questions, or is it already the case that they go and get the Wikipedia articles based on the question?
Well, yeah. So like they look at the question, like now they've added the answers in as well, and then they use the sentence transformer, and then they compare the sentences that are formed against the Wikipedia pages. So in the Wikipedia pages, like obviously they've just been sort of extracted from Wikipedia, so you could maybe tidy them up a bit. The other thing they do as well, they've like sort of pushed it as far as it can go in terms of the size of the context. So they've just like added 1 or 2 extra bytes onto the context size, but they do look as if they just like sort of truncate it in the middle of a word or something. I was wondering, would it be any advantage to make sure that you have sort of complete sentences in as opposed to just chopping it off in the middle of a sentence?
But you're saying they already use this sentence transformer to kind of map, if you will, the question plus the answers, and then find the most relevant wiki pages, and then post-process it a little bit to get the context.
Yeah, and there is a discussion and a notebook that lets you use like a range of different sentence transformers. At the minute, there was only one being used, but so I'm not sure is there any advantage to using a different type of sentence transformer.
Yeah, I think there's a whole range of things you can change on the that side also, right?
Yeah.
You can use multiple sentence transformers. You can use different embedding sizes. You can talk of different ways of what is that? How you chunk your Wikipedia articles. At least, yeah, right at the top of my, there are 3 different options there itself, and I don't know how much.
Or how best to, does the sentence transformers give you the best match?
So the match is, it's just
between,
taking it into a new embedding space, right? And Wikipedia has also taken with that same sentence transformer into that same embedding space. And then it's all about,
and then finding the distance.
yeah. So there is a, so if you have probably, there must be some optimum number of embedding length that you can use there, which will be the best. Like, for example, I don't know, like ChatGPT or something uses like some 1500 vector space. We are using, I think, 300 or something. So
yeah, I was wondering how they compare the match and whether that is a function of their sentence transformer or that's another independent.
oh no, that so Face,
choice.
if I'm not wrong, under the hood uses something like an L2 metric, it'll be, right? You're just trying to see which 2 embeddings are close.
Close, yeah.
Yeah.
And I was just wondering whether there are different ways of judging that closeness, or everybody is using this Face, which just uses a.
At least from the notebooks I saw, Face is all I saw.
Yeah.
But I'm sure Face under the hood will probably let you use other ways you can match things to embeddings, but yeah, I don't know.
But I think everybody is using kind of Face, and probably its default.
Yeah, probably. Yeah.
So where are you at, Rekal? Where did you, with your experiments, where have you ended up?
Right now, I think I'm somewhere between 300 and 400. Have like 3 or 4 ensembles, but those are only like fine-tuned with freezing, not without unfreezing the whole thing. That's my next one that I was trying. And actually, next I wanted to try was some, at least read so much about LoRa and use LoRa for imaging stuff, but I'd be curious to see how, to train something with PEFT and see how that, I mean, I saw in the discussion board that doesn't get you great results compared to this, at least that's what I saw in Chris's discussion. But I don't know. I think that is more to do with PEFT with like a Debata model rather than maybe PEFT with like Llama 2 or something.
Yeah. See, by the way, that's why I keep going to. I haven't seen any. Well, I haven't looked hard, but I haven't seen too many people fine tune or use PEFT, LoRa, and stuff with Llama 2 and use non-perplexity means to judge it and then evaluate it. I haven't seen that in anything public posted. I've only seen Debata used in that way. And then, if you're just doing Debata, then you don't need PEFT and LoRa and all that to.
I think if you fine tune the whole thing, you probably need. Because that's the problem I'm facing now. It's sitting for so long.
That may be.
Yeah, like in Chris Dayot's training notebook, does he not use like PEFT and LoRa and stuff?
No, there's no PEFT or LoRa.
Is there not? No.
Yeah, the only way he's got around even publishing that notebook on Kaggle for it to run is using freezing. So he's freezing a bunch of layers, and not even training the embedding layer or any of those things. And I think his the what is that? Not the context. The sequence length is also pretty small. So changing those things itself are like a bunch of options to try.
Yeah, so like where I am at the minute with the Llama 2 stuff, it was just sort of, it's got like Q LoRa or whatever, so it's using the 4-bit
Orbit.
thing.
Okay.
So I don't know, like, will that sort of take the accuracy down so much it'll train
But
reasonably
I feel
quickly?
like when you do the ensemble, that should give you a like completely different look than the Debata side, right? So
Yeah.
I think at least that's my hope, and that's why I want to try that and then ensemble that approach. But yeah, I never saw that new curated, which you were talking of, 1,000 samples. And that is interesting. I want to try that out. I've been just using those 200 as my test set, which is really finicky with map as a metric.
Yeah, so this one's good, and it sounds like the guy spent a long time cleaning it all up. So
Nice. Okay. Yeah, that is exciting to try with.
Interesting. So Mayank, were you able to try anything?
Yeah, I've been experimenting with a couple of notebooks that are there in the top of the leaderboard with the open scores. So I've been playing with them and getting to know them with respect to the ensembles that they try to represent. The LLM Psi X optimized ensemble weights better models notebook, which has a score of 0.84. So I'm working on that. Let's
I
see.
Cool. So any additional ideas on things to do other than what already Rachel and Steve have shared?
No, I'm dabbling in the same stuff that you guys discussed, so I'm good here.
Yeah. Anybody else? Any other thoughts? We have what, couple of weeks left to go?
Yeah, 3, I thought.
Where is the leaderboard leaders at? 0.91 last I checked. Anybody see what
17 days left.
Oh, okay.
17 days. Okay.
Yeah, so not a lot. Just enough time to train one model.
But it's, yeah. Is that time to whatever form teams, or is that time to the end of the competition?
Yeah,
Oh,
24 days to go.
Oh, sorry, 24 days, 17 days to merger. Yeah.
Merger. Yeah, 17 to merge. 24 to.
So you'll finish right in time to merge, Steve.
Yeah. How's it going with you,
That's the thing
Terrence?
about this.
It's
Are you
good.
top of you top of the leaderboard yet?
No, I wish, but I did do the copy with the copy run type scenario. So I'm just going through the code now. So
Did it work out okay for you?
yeah, it did. It did. So it got published last night. Now I just need to go through and better understand what it's doing.
Glad to hear you're finally on the leaderboard there. So the only way is up.
It's funny.
How about you, Emily? Have you tried?
No, it's a bit daunting to dive into for me right now.
It's like what I was like saying to Terrence, though, the best way to start is just go on the public leaderboard, just find the top scoring model and copy it. So you just copy it, save it, and then when it finishes running, you'll get a submission file and you just submit that. If you do that, then you'll be on the leaderboard and have a reasonable score, and then you can like take your time to go through the notebook and see is there anything you think that you can improve on. So it's a good way to get started.
Yeah. Okay.
Yeah, and those notebooks get you like halfway, and I don't know, it feels good that you can at least run someone else's notebook, which is out there in public and no one else seems to be doing it. And then when you start tweaking and push your way up, I don't know, it feels good.
Yeah, especially if you get up early in the morning.
Starting.
if you find like a public notebook just first thing in the morning that somebody submitted and nobody else has copied it yet,
Oh.
you can get really high up for a couple of hours until everybody catches up.
Oh, okay. That's a good tip. Okay.
Yeah.
Yeah, it kind of gets you past this starting problem in most cases,
Right.
right? Like you just have a struggle to say, oh, I'm going to do it, but you never do it. And you kind of get past that. And once you get on the leaderboard, as Steve is saying, then there's a lot of motivation to keep pushing,
Calling up,
especially when people, especially when you are like, as Steve says, you're like up and then everybody bypasses you and like, no, I've got to do something here now. What the heck is happening? And you wouldn't have that motivation otherwise. You're kind of constantly like, I'll get around to it. You kind of get you past that hurdle. That's a good thing about Kaggle.
I see.
And, sharing and stuff is you can get off and just do something, and then that motivates you to kind of keep trying.
Yes, like the real-time feedback that you get back from the leaderboard, which tells you
Right.
where you are.
Oh, yeah, that too. And the data is right there and stuff, right? So you can, it's those things really help. Good deal. Okay. Nothing else. Thanks everybody for joining, and see you all in a week.
Okay, cheers. I'll see you next week.
Thank you.
Thanks, everyone.
Bye. Bye.
Bye.
Thanks, guys. Take care.